Hello, good afternoon. I'm Eric, and joining me here is Francisco. By a show of hands, let me know how many of you have worked with maintenance notifications before. Great, we are in the right place. So for those of you who aren't familiar, maintenance notifications are messages that are sent, typically from providers to customers, sometimes between peers who exchange data directly. They're often delivered via email, and they are manually processed in many cases. And of course, whenever you do anything manually, certainly when I do things manually, sometimes I make mistakes. They also take a lot of time to process manually. This is something that can consume a significant amount of work on the part of our operations teams to react to and respond to. So it's an area that's ripe for automation. There's a lot of work that can be taken care of directly by computers here, much better than humans, but there are problems that prevent us from doing this, largely due to the fact that many of these email messages are intended to be consumed by humans. They're not really designed for computers to work with. What we'll be talking about today, we'll be going over Facebook's approach to automating maintenance notifications. Francisco is going to go into this in detail. In particular, he's going to address some of the challenges that they've experienced trying to take the human out of this process. That motivates our work towards standardizing the format of maintenance notifications. We'll talk about those standards by showing some examples of how they can be put to use, and then wrap up talking about what we are working on next.
So, as Eric mentioned, processing maintenance notifications and maintenance in general is a hard thing to do. And I'm not even talking about here about automating. I'm talking about even manually. It's a very time-consuming and error-prone process. At Facebook 2 years ago, we started having this problem where we were spending much more time than what we were willing to spend on maintenances, and we decided to do something about that. One day we had a maintenance that was about to start in less than an hour, and we noticed this maintenance. It was more than 30 circuits, and we started working on it to try to take the traffic away from those circuits, right? And at the time, we didn't have any automation, and we had some scripting and some data that we could convert some of the data into actual circuits, but it took a lot of time. By the time that the maintenance was starting, we were finishing with this, and we noticed that we didn't really have the capacity to take this maintenance, right? So that's when we decided to create Carrier Maintenance, which is a set of tools that helps us automatically parse the maintenance notifications and take action on this. So to give a brief description of how the workflow of this system works, we receive emails which are received by the scheduler, and the scheduler sends these through the Carrier Maintenance library, which is the library that we use to parse the emails and basically extract any information that we need to schedule these maintenances. So when the data comes back, we save it as events in a database. On the other hand, we have a Carrier maintenance worker, which is constantly checking the database, checking if anything is about to start we do it in less than an hour, but this is obviously something that can be changed. And in that case, we do a couple of things, which I will describe in later slides, and ultimately act on the network to be able to make that this maintenance doesn't affect us. So first I will talk about the scheduler. There is a set of things that we support in the scheduler. We support right now more than 30 provider templates that we automatically parse. We support scheduling maintenances, which is basically any new maintenance that we have, we schedule it in our system. But we also do event aggregation, and this is because many of the maintenances that we receive are related to other maintenances that we already received before. And the reason for this is that carriers send more than one maintenance generally, and they can be reschedules, they can be cancellations, they can be addition of circuits, addition of dates, a lot of different things. We usually do this using the maintenance ID in the maintenance notification to group everything together. Another thing that we do is fuzzy matching of circuits, and there is two reasons of this. One is that sometimes carriers are not very consistent on how they send the circuits. Basically, for example, the provisioning team and the maintenance team, they may send different circuit IDs, which are basically the same circuit ID for a human, but for a computer, they may be slightly different. They may have included spaces in the circuit ID, and then on maintenance, they remove them, or slashes instead of dashes, or stuff like that, right? On the other hand, it may happen that it's our fault. Our provisioning teams see spaces on the circuit IDs, and they may simplify it for database storage, right? So that obviously is fixed, but until then, we need to be able to parse this. The other reason why we do fuzzy matching is that we receive a lot of emails that are not really pertinent. For example, if we cannot parse a maintenance because we don't have a template for that, that may be a valid maintenance or not. And the way that we discover this is that we get a list of every circuit that we care about in our network, which is a lot, it's thousands of circuits. And we basically go through the email or the maintenance notification and check if any of those circuits that we care about is there in that email. If there is nothing that we detected there, we basically drop the email because it's probably not something that we care about. If not, and there is something pertinent there, we will escalate it to a human, but that's the only case we want to escalate. Another thing that we started doing recently is that we started rejecting or confirming maintenances with certain carriers with which we have an agreement. So basically, if we detect that the template is for this carrier, but there is a problem in this, in how it's formatted, we send an email and say, we couldn't read this email, please send it again. On the other hand, we also confirm that we could schedule the maintenance, and they will know that they don't have to do anything. There is a pre-agreement that if we don't send a confirmation, then they will try to contact us or send another notification. Some of the stats for the scheduler is we receive thousands of maintenance notifications a month, of which about 10% are new. So these are easy to process. We just create a new event. About 40% of them are related to previous notifications that we received. And these are the ones that are really hard to process even by humans, right? So detecting that we already have that in our database and checking what's the difference between what we received before and what we need to do now, it may be quite time consuming. And the other 50% are the ones that we are not interested, and this may be, as I said before, like there is a lot of emails that may arrive to this email box. They may be basically things that are not maintenances, for example, tickets and stuff that they are sent in errors, or even maintenance notifications that they are updates that we don't care about. So for example, a reminder that the maintenance is about to start, or updates during the maintenance and stuff that we decided not to process. What this means is that every month we would be using about 2 engineers to process these maintenances manually and doing everything that we do with automation. And this means more than 400 engineers hours a month. So one thing to note is that these are not like 1 or 2 maintenances a day. We are having some days more than 10 maintenances, and some of these maintenances are more than 30, 40 circuits worth, right? So now let's talk a bit about the worker. So there is a set of features that we support in the worker. One of the main ones is audits. And before the maintenance starts, we do one important audit, which is capacity simulations. The capacity simulations, we do it periodically in our network, so we leverage this system in the worker. We just do a refresh when the maintenance is about to start. And the idea of this is to check if the maintenance may affect us when it's going to happen. We also do this at the time of scheduling, but the problem with that is that at the time of scheduling, we may detect things like a single site that has two paths. They have two different maintenances that affect one and the other path at the same time, so we may reject that at scheduling time. But that doesn't mean that we are going to be safe at the time that the maintenance starts, because the network will change in that time. We may have a fiber cut going on, or we may have provisioned new circuits or decommissioned some other circuits, right? So we do this at the start of the maintenance. If we see any problem, we do automatic cancellation of this maintenance, or at least we try, right? So we send an email to the carrier asking for the cancellation, and we also alarm internally so that a human can be engaged depending on how serious this problem might be. If everything goes well, there is a deprioritization of the traffic in the circuits affected, which means that, well, traffic won't go through those circuits. And after the maintenance, we also have a set of audits that will check for errors in the circuits, CRCs or any other error, and also if the circuits are up or not. Here we also leverage some other system that we have in place already for fiber cuts. And we basically treat it as a fiber cut, but we know that it has to do, is related to the maintenance, right? So what we do is we send an email to the carrier and we follow up automatically with the carrier until this is resolved. So what this means is that, well, we were spending 2 engineers worth of time a month just for the scheduling, but if we account for everything that we have to do for actually draining the traffic from circuits, we will be talking about 5 engineers at least, and more than 1,000 engineer hours a month. So this graph is just an example of traffic in a circuit, in an actual maintenance that we have. It's showing the 2 lines, the start of the maintenance, the end of the maintenance, how the traffic an hour before the maintenance is being drained. At the time of the maintenance, there is no traffic, and after the maintenance, well, the traffic automatically returns as soon as the maintenance ends. Last, let's talk about the workflow, the library that processes the emails. So the things that we parse in the maintenance notification is the vendor, the maintenance ID, the number of dates. This is because some maintenances have more than one date where they will work. We parse the start date and end date for each of the dates that are involved, if the maintenance is service affecting or not, and the circuits that are involved. Obviously, this is not everything that we could support. It's just what we decided to support because it's what we care about. Obviously, the system could be extended to support saving the description, the contact, and stuff like that. We already have that information in other places, or well, at least the contact. So we decided to just care about this. Some of the challenges of parsing, well, basically, the first one is we are parsing emails, right? And parsing emails is hard. It's not meant to be read by a computer. So that's the main problem. We have unknown templates, so the carriers will use a template normally, but we don't know how it works. When we see a template, it's pretty obvious what we have to do and what we have to parse, but that's just the base template. So we may parse what I showed before, but what about when we receive a cancellation? How will that look like in a new template? Will they put that as a note in the maintenance? Will they put it as something in the title? We don't really know. So the only way to find out is, well, to see what we receive in the future. Another problem that we have is templates change. So this again, the emails are not supposed to be read by a computer, right? So carriers may just change the template and they don't see a problem with this because they assume that a human will read this, so a human can read any template they send. So as long as the information is in the email, who cares, right? Well, we actually do. So another one is human errors. Many companies have templates, but the actual templates are not really filled out by automation systems or computers. They are filled out by humans. And many errors come from that, like dates are not formatted the same way in each email, or even very small problems like an additional space in some place may cause a problem if we don't have this into consideration. On the other hand, handcrafted maintenance is another problem that some carriers may do, and also having, for example, maintenance, we've had maintenances attached as a PDF on an email, which is extremely hard to parse. Besides this, there is some other problems that we saw, which is they are not inherent to parsing the emails, but for example, some carriers wouldn't send a maintenance ID with the email, or we've seen also carriers reusing maintenance ID from before, so our systems fail trying to match this to a previous maintenance. So this is all I had. I will pass back to Eric, who will talk about the work that we are doing to make this last part easier to do.
So as Francisco mentioned, there are a number of challenges to parsing these emails, and all of them stem from a lack of standardization. These emails are inconsistent across different providers, and they're inconsistent even within a given provider. So what we've been working on with a number of other people is to establish some kind of conventions for how to format this information. Key among them is to establish a list of mandatory fields. What we've aimed to do is identify what we think are the minimum information that are required to automate and dispatch this kind of work internally, and then to say those things are required to implement the standard. Of course, you can do more than that if you want, but we're trying to keep it as small as possible. As part of this, we're looking to extend the existing iCal format. At their heart, maintenances are basically events and that take place in time. And so iCal is a great way that already exists to schedule events across organizations, and we're looking to use that as a basis. When we do that, a lot of things come for free, like handling time in different formats and different time zones. And we also get the benefit of a deployed base that we can interoperate with. We have a draft standard that's available for review, and we also have a number of Python libraries. We participated in the hackathon this past weekend. That was a great experience. We got a lot of benefit out of that. The libraries are greatly improved for handling the generation and the parsing of these messages. We also were able to, thanks to the help of Russell from Lynx and Cody from Facebook, create a proof of concept integration with a ticketing system, as well as add a bunch of unit tests to ensure the quality of the code over time. So example workflows, Francisco mentioned a circuit going out of service, for example. I think that's a great use case to think about. You could also apply this to BGP peering sessions or transit services, et cetera. But if you take the circuit case, you can think about a circuit going out of service at some point in time, the provider needing to notify customers for that. And then what would the workflow be for the consumer of that notification? One common thing is converting timestamps from whatever the provider hands you to something that's meaningful to you. You might also perform ticket creation or add information to perhaps a common calendar. Because we're extending iCal, the calendar edition comes for free. That's something that you can take advantage of without any kind of automation work internally. And then if you want to do more with integration, then you can move on to more advanced things like ticket creation. So an example of what this workflow might look like, the first thing, and that animation didn't work. The first thing is to start off determining that a maintenance is required. That's what the provider will do. They'll list out all of the affected services that are associated with that work. If you have an element in a path of an optical network, you might have many services running over it, so you need to figure out what all of those services are. Then you'd list the affected accounts associated with that to gather data that you'd use to notify the customer, such as email addresses. Generate the maintenance notification email, and again, this is something that would exist with the standard in exactly the way it does today. We're not suggesting that anyone change the human-facing content that they have. You would generate a iCal attachment. This is the information that's formatted for the computer, and it's brought alongside the existing human-facing information, and then send that email on to the recipient. The recipient would receive that information and then look at its contents to determine if the standard has been implemented. If it has, that can be passed off to a program to parse and, for example, generate a ticket. And if there isn't any computer formatted information in there, the email can be passed on to a human parser for the same process, only done manually. And this is a huge advantage. This can save a lot of our organizations a lot of time, even if you don't go to the extent that Francisco and Facebook have. There's a lot of needless work that can be eliminated if the standard is available. Here's an example of what a formatted message looks like. This would appear in an attachment to an email. And as you can see, it fits on one slide. It's still fairly readable. The complexity here is not too great. Most of this information is standard iCal. There's only a small amount of it that's actually the extension. And as you can see, we're taking advantage of the existing mechanism within the iCal standard to extend it. We've tested this for compatibility. We found that all of the calendaring systems that we've tested silently ignore all of these extra fields. So again, you get backwards compatibility with existing deployed calendar systems. Some of the fields of interest in particular, there's an identifier field. This is like a row ID in a database table that you can use to associate different updates with each other, even if all the other related information about the maintenance changes. There's a sequence field, again, part of iCal, and this orders the updates, so it's possible for you to know what is the newest information in case the messages get delivered out of order to your parsing application. There's a field to uniquely identify the provider, so we know who exactly is sending this notification. We have a field to identify the account in case within an organization we have more than one group that is using the services of this provider and we need to dispatch internally. Then we have a field to identify the maintenance. If I need to call the NOC for this provider and tell them, here's what I'm talking about, this is the maintenance I'm referring to, this is the field, the information in this field is what I would use. And then finally we have a object identifier. Now this is very generic. We haven't said exactly what this needs to be. It's a text blob in our standard. You can put in a circuit ID, for example, or an IP address of a BGP peer, whatever makes sense within the context of the service that you're notifying for, to identify that service to the consumer, to the partner, to the peer, et cetera. That's what you would put in this field. And we allow more than one of these for each notification. And the last field is a field to determine impact. In this case, no impact. There are other impact levels that we've standardized, such as an outage, degraded, or reduced redundancy. Next steps for this process, we are here today to get input from all of you, and we continue to seek community input. We very much want to hear what you think about this. Some questions we have are, does this solve meaningful problems to you? Are there additional things that we should be looking at? Is this too difficult to implement, or are there other issues that you want to let us know about? We're going to be trying to identify people who are interested in adopting this and implementing it in its early form so we can get some operational experience and learn from that to understand where we need to make improvements or where we may have significant problems. We'll take both of those things and use that to refine the standard and then run it through some sort of standardizations process such as the BCOP or perhaps an RFC. Once we've done that, it's time to advocate for the implementation of this standard. So we intend to do that in part by developing some boilerplate RFP language so that support for this standard can be included in the purchasing process of services, and also continue to engage with various communities and encourage people to adopt this standard. And also work to continue to develop proof of concepts and show how this can be useful to other people in tooling and automation. We'd like all of you to get involved. Please feel free to reach out to us, both here and in the future. Some groups we're especially looking to reach out to us and to engage with are carriers, We want to work with you as well as ISPs, IX operators, people who peer at internet exchanges, and coders, especially the people that work on tooling and automation in your organizations. They may not be here today, and we're asking you to take this information back to them and help us get their feedback. We have a Facebook group where we coordinate a lot of our discussion and work. Our code for the libraries is also available on GitHub. And with that, we will take your feedback and questions.
Hello, Brandon Ewing with DataPipe. My first question is the code being provided, does that include the templates that were discussed by Facebook and the human parser, or is it more focused towards the BCOP stuff?
Yeah, the code libraries are focused on the BCOP. So the Git library or the Git URL that I mentioned is all focused on the BCOP, and I'll let Francisco talk about the things that he's working on.
Yes, so no, the other code is not provided, but we are working on trying to make this available. Currently it's very Facebook focused, so there is some work to do to detach it from that, but yeah, there may be some news in the future.
And the second question, is there any discussion yet about the security considerations for the protocol? And Francisco talked a lot about automated actions on routers from the result of these messages.
Yeah, that's definitely a concern. The draft standard has a section that addresses the security concerns. That's a problem that exists today. We already have that issue, not just if you automate, but even if you're manually processing. It's possible for someone to craft a malicious notification that we might react to and that could cause harm to our networks or to our customers. There are options for securing email out of band of this particular standard. For example, PGP would be the most obvious choice here, I think. There's also options out of band of email. Within the iCal standard, there's a notion of using CalDAV as a means for exchanging calendar information. That's more of a publish model as opposed to a push model. And that can be secured with TLS. So those are two mechanisms that we think are available to address some of the security concerns that this, of course, will bring up.
Thank you very much.
Matt Petak, Yahoo. On the CalDAV thing, I think you'll probably want to approach this from a parallel track perspective in that trying to use email to carry this forward. I'll just speak for myself. You guys seem to be infamous for generating lots and lots of maintenance notifications on, hey, we're going to touch a router and links. Here's 15 copies of the alert notification. I understand the sequence number. I understand having an automated system generating these. Email is not the right transport for doing that. Save the email for things that humans will look at, because the poor humans who are going to be not yet automated on the other end are going to hate you for this. So please keep in mind that this will be great for interfacing with other people with automation, but not great for interfacing with people who still read through manually, because it just generates more of those engineer hours you were talking about. Thank you.
Yeah, I think that's great feedback. And perhaps this might be a good transitional mechanism that we use to jumpstart the process. CalDAV obviously is a great way to shift this over, and that's available to people. That's feedback we're looking to hear, and hopefully we'll get some operational experience with this, and we can identify maybe what a better strategy is for this longer term. But yeah, we'll take that back and consider it. Do you want to talk about anything related to notifications?
Hi, Joe Nelson, Google. So I had a question about your capacity simulations. And I think you mentioned that your target is to run this process within the hour before maintenance. Have you had any struggles with limiting the runtime of that simulation? And then a follow-on question is, do you have any data about how many times you've received the maintenance notification, but maybe in your architecture, in your network, it just didn't matter? And so in that case, what do you do? Not take any action or still do the drain?
Can you repeat the first, if I have a problem with that, what?
So the capacity simulations, do you have a target max runtime on that? And have you experienced any issues keeping it to that max window?
Yeah, so the way that this works is that we have, I'm not really sure about the exact time window, but basically we have a baseline of how much bandwidth exists in the network that we use normally. And with that, we assume basically what we are going to need for any single day. We do it with a couple of days from the moment that we do the simulation to a couple of days after to see how the bandwidth will look in that time. And we take into account what maintenance is happening that time and what fiber cuts we have open, right?
Thanks. And the second question was, do you track how many times you've received the maintenance notification and whether or not you actually needed to do anything?
I don't have a number. In general, they can go through, but we've had some important ones which we detected and it saved us from serious problems, right? But it doesn't happen very often, but it's still an important thing.
Okay, so I guess it's safe to assume that you always drain in response to the maintenance request.
Normally we do, yeah. And one of the things that we also do, and also for security, is that we don't what we call hard drain. We deprioritize the circuits. So even if something would happen and we had some issue that we drain more than we should, the traffic shouldn't go through those circuits, but in cases that we need those circuits, they are going to be used.
Okay, thank you.
Yeah.
Hi, John Sane with NTT. My question is about the email parsing. So we get carrier notices all the time, and they have, HTML notices, plain text, and sometimes attachments. Do you guys sanitize that data, validate the data, like to look to see if the dates are correct, or because sometimes they'll put multiple time zones, but one of the time zones will actually have like the wrong date or wrong, maintenance time with it. Do you guys like take that information, compare it to itself to see if they match the same time, and then continue on, and also, sanitize the data, validate the data before you actually proceed with the actual parsing of it?
Yeah, we do some sanitation, but it's hard, right? Because how do you know that is actually, like, if the date is in the past, for example, it happened, well, we basically check those kind of things and we alert. But sometimes, for example, we assume that a maintenance with a different date, it just means that they have rescheduled. Sometimes we do that, so it's hard to relate, because some carriers will just send you a new notification that will overwrite the last one. Sometimes they will clarify there is a reschedule, sometimes they don't. So it's hard really to know how to parse this, even for a human. So, yeah.
Gotcha. Thank you.
All right. Thank you very much, folks. I really appreciate it.